start with the lesson. So what is this topic? So we call it statistics or data handling. And I just wanted to show you a little something from the CAPS document, just so you know kind of where we're heading. So today is going to be something called central tendency, or where is the middle, okay? And then the next lesson will be about, so if the first lesson is about where is the middle of the data, the second lesson will be a lot about how spread out is the data. So, how do we tell if something's very close together or spread out? And then if we look at the third lesson, it's going to be about something called the box and whisker plot, which is like a graph that summarizes data. Then the fourth lesson is going to be about grouped data. So how do we group data into intervals? And then the fifth lesson is going to be about a different type of graph called histograms and frequency polygons. And then the sixth lesson will be about something called ogives, or cumulative frequency curves. So that's the 6 lessons that we will do. And we'll also talk a little bit about things like outliers, like what is an outlier? We'll also talk about what it means for data to be symmetric or skewed to the right or the left. So give me a thumbs up if that looks vaguely familiar to you. Give me a thumbs down if that looks very odd to you. I mean, a lot of it is new because it's new work, but just so you know kind of the ballpark that we're playing in today. Okay. Okay, so it's not a problem if you don't know yet, because this is, but it's just to give you some guidance. Okay, cool. Let's start with this. So if we talk about the world of data, there's 2 ways of representing data. The one way is using like words and letters, so like ABCs and things like that, or punctuation marks. And we call that qualitative data. But we don't spend too much time in this unit worrying about that. Most of the data we worry about is something called quantitative data, or quantities. And quantitative data is written in terms of numbers. But within that data set, there are 2 different types of data that occur as numbers. There's data that occurs as discrete numbers. So basically, when there's no fractions, there's just a discrete number of items. So like the fingers on your hand or the number of people in the room, you can't have a fractional part. And then another type of data that we have in this topic is called continuous data. And that data is data, there's things like we measure. So maybe it's like how tall you are or how much you weigh. This type of data can have fractional parts to it, or pieces of the whole. And so to start off today, I just want to say in this unit, we're focusing on data in terms of numbers, and it's important to know the difference between discrete and continuous data. So let's have a look at some examples. So here's from a note: discrete data can only take on certain values. For example, the number of students in a class, you can't have half a student. Or if you're rolling 2 dice and you were looking at the sum, you can only have the numbers 2, 3, 4, and so on, up to 12. You can't have 5.5. Give me a thumbs up if that makes sense to you. If the idea of discrete data makes sense to you, give me a thumbs up. Okay, so that's our first little bit of word for today, understanding that when we talk about data in numbers, we have to understand this thing called discrete data. Now, what about continuous data? Now, for continuous data, it can take on any value within a range. So, for example, a person's height can be any value within the range of human heights, not just certain fixed heights. So you can have, I'm 181, but you can also have someone who's 160.5 centimeters, or you could have someone who is 149.87 centimeters. So this type of data can be stored with fractional parts. Or another well-known one is time in a race. So like in the 100 meters or Formula One, we measure time with lots of fractions. So give me a thumbs up if the idea of continuous data makes sense to you. Give me a thumbs down if the idea of continuous data seems very odd and strange. Again, I'm just getting a feel for the room because I can't always see everyone's faces. So the thumbs tell me how you're feeling. Okay, so if you're feeling lost, don't worry, we're going to do some questions now. Let's have a look at the first question. So here are your options. Which one of the following is discrete data? And I want you to tell me, have a look at A, B, C, or D. Which of the following do you think is discrete data? Okay. So I see a lot of students seem to be going for B. Sean has 2 brothers and 1 sister as discrete data. And I agree, because you can't have, even if your brother or sister is smaller than you, they still count as one person. So this would be an example of discrete, and this would be an example of continuous, continuous, and continuous data. Okay, 100 meters could be written in 10.2, and that's why it's not a discrete data. All right. So which of the following is continuous data? So which one of the following items is continuous data? So 2 eyes, discrete, 5 kittens, discrete, 4 paws, discrete. But she weighs 5.4, well, that's going to be continuous data. And so the way that I think about it in my mind is it's going to be discrete if you count it. It's going to be continuous if you measure the data. So if you measure it, so like the temperature, your weight, your height, if you measure it, it's continuous. If you count it, it's discrete. That's what I always use to remember. Okay, so that's going to come up later, but for now, that is some basic data stuff to start with. Now, if we look at data in general, there's 2 different ways that we can look at data. We can think of data as a list. So I've got a whole bunch of heights from a class, and this is called a list of data. And this is a common way of representing data. You just collect it from a class and you make a list. Sometimes what we have to do is we order that list from smallest to biggest, and that's called ranking the data. So we go rank the data means to arrange from smallest to biggest. And sometimes they'll say to you, rank the data or order the data. So I think most of you are familiar with lists of data, but sometimes what we do is we put data into intervals. So, and what we do is we take data and we put it into a table. So I want to just do this little exercise with us and just go through some more terminology. So what intervals do you think I should use for my data set? Here's my data set. It's students in a class. What intervals do you think would be a good way to summarize this list of data into a table? Put your answers in the chat, or you can raise your hand if you want to let me know what intervals do you think work well. Morgan has said going in tens. I agree, Morgan. And so the question is, where should I start? Well, I think if I scan through my data, the smallest value or the minimum value is 149. So why don't I go from 140, and in fact, let's use that notation where I include and exclude. So from including 140, but excluding 150, And then let's start and go 150, including 150, excluding 160. Then let's go 160 to 170, and I include 160, exclude 170, 170 to 180. Is that enough intervals, or do I need another one? What do you guys think? If you look at the data, what do I need any more intervals, or will that cover my data? It's enough? I did spot them. I was looking for the maximum value. What's the maximum value? I think the maximum value is 182, and that doesn't fit in this interval. So I'm going to make another interval here. And I'm not going to go to 182. I'm going to go to 190. Okay. So often, one of the things we have to do in the section is know how to group data into intervals. And sometimes we use a tally. So I'm going to show you how to use a tally. 169 is going to be in this interval. So I'm going to make 1 mark. 155 is going to be in that interval. Make 1 mark. 182, that interval. 154, that one. 162, that one. 168, that one. 149, that one. 155, that one. 175, that one. 167, that one. 159. Now, I have to be careful here. 159 is going to be in that one. 166 is going to be, and I cross that for 5. So the tally is just a visual indication that helps me summarize it. The frequency is how many times it occurs. And so the frequency count for each of my intervals is going to be that. Give me a thumbs up if you've seen your teacher do this before, and the idea of going from a list to a table makes sense to you. Okay. Now, if I have to ask you, which one, so in fact, we'll come back to that in a moment, but I just want to show you something called cumulative frequency. Okay. If you have a table and you have tally and you have frequency, you can also do something called cumulative frequency. And what it does is it counts up the frequency for the intervals. So I'm going to say the cumulative frequency in interval 1 is 1, but the cumulative frequency to the second interval is 5. What do we think the cumulative frequency is going to be in the next block? Okay, it's going to be 10 because we add whatever frequency there was already, which is there. And then the next one after that, you've got 10 items up to 170, but then you've got 11 over here. And if you've got another, if you count another one, in total, we'll get 12. And so there's 12 items in our data set. And so you will see this process of putting things into tables occur a lot from lesson 4 onwards. But I just wanted to, or lesson 3 onwards, but I just wanted to make sure that you had some basic ideas here. Now, if I asked you, what is, before I move on, what is the modal interval? Maybe someone can tell me, what does the mode refer to? What is the modal interval?
Sir?
Yeah.
I'm not understanding how you got to the cumulative frequency from 1 to 5, then 10, then 11, then 12.
Okay. Can you see the frequency column over here?
Yes.
In row 1, there's 1 item. There's the frequency of 1. But if you
Yes.
accumulate the frequency, if you add how many there are in the first row and the second, can you see 1 plus 4 gives you 5? So there's been
Yes.
5 items up. And then if I had to go to the next one, I go, how many have there been up to this point? 1 plus 4 plus 5, and that gives me 10. So it's saying there's
Okay.
10 items on there. Yeah,
Okay. Thank you.
perfect. Good question. So the modal interval, the mode means one that occurs the most often. And in our table over here, the one that occurs, the one with the most items in it is this one over here. It's got 5. And so we would say the modal interval is from 160. Another way of saying it would be like this. It's all the values between 160, including 160 and less than 170. And that's called the modal interval because it occurs the most. Okay, I think we're ready to move on. I just wanted to give you, so far we've talked about the types of data and how we have data in lists and how we can have data in tables. Let's move on to knowing where the middle of the data is. So I'm going to focus initially on lists of data. The middle of the data are the following. The mean is if we add up all the numbers, we divide by how many items there are. Okay, so it's like, often you'll see it like the sum divided by n, the number of items. The mode is the one that occurs the most often. So the one that you see the most often. And then the median is another measure of where the middle of the data set is. But for this one, we have to rank the data, or we have to order it from smallest to biggest. And then we find where the middle of the data is. And so I'll give you an example of how this works in a moment, but we're just going to, I just want to check that these 3 words, mean, median, and mode, give me a thumbs up if you've seen them before and you have some idea of what they do. Okay, so let me give you an example of how this will work. So for the data set below, let's let you do this initially. I want you to find me the mean and the mode for this data set. So based on what you know, find me the mean and the mode of this data set. What is the mean? What is the mode? So to find the mean, we have to add up all the items and divide by how many items there are. It looks like there are 9 items to me, but I still need to add this up. So for the mean, I get 3. Now, what about the mode? What are we going to get for the mode? Pop your answer in the chat if you feel like you know what the mode is. Okay, so the mode is the one that occurs the most often, and I can see that there are 3 ones, and so the mode is going to be the value 1. Now, I haven't found median yet, so this is a measure of where the middle, or a measure of central tendency. So is the mode. I left the median out. Why? Who has a guess of why I left the median out? Maybe someone can tell me, why do you think I left it out? Why is it a little bit more tricky for this example compared to the other 2? So Morgan has said you have to rank the data or order the data because we haven't arranged it. Yes. So what I want you to do is let's order the data together. So I know the smallest number is 1, 1, and 1. So I'm going to cross that out. Then the next one is going to be 2 and 2. So I cross that out so I don't get confused. 3 is that. And then I get 5, and then I get 6, and then I get 6. Okay, now, I've now ranked my data, but here's the problem. There's different ways of finding the median, and what I want to suggest is we use a position formula. And the position formula for the median, and you'll figure this out in the next lesson, is called Q2. So what I do is I do a little position calculation. I say position of Q2. Now, in case you're confused, the Q2 is just the representation we use for the median, and I'll talk about that in the next lesson. And the way the calculation works is because it's in the middle, it's a half times n plus 1. Okay? Now, that isn't the value. The value of the median, or Q2, is going to be in the list. But first, I'm going to do this little calculation. And so I'm going to say a half. Now, n was 9 because there are 9 items in the list. Here's the 9. If I count them, there were 9. And so we go 9 plus 1. 9 plus 1 is 10. 10 times a half is 5. So I say the median is in the 5th position. Now, what does it mean to be in the 5th position? I count from the beginning and I go 1, 2, 3, 4, 5. And we say the median is going to have the value of 2. And what a lot of students feel a bit confused about is how this position calculation works. And we're going to practice it a bit today, but I just wanted to give you an example of how it works. Q2 is another way of saying the median for those who are unsure. Okay. Michelle, I will definitely show on the calculator later in class. I just want to, first of all, get the basics under us. Now, the range is not a measure of where the middle is. The range is a measure of how spread out the data is. And the range is simply the biggest, what we call the max value, minus the min value. So what do you think the range is going to be for my data set here? Okay, so the biggest value is 6, the smallest value is 1, so we get 5. So that is the range. Okay, so what have we done so far? We've looked at the 3 measures of where the middle of the data is. We've looked at how the median is a bit different, and we also did one bonus question on the range. So let's go and get ready for a second example. Now, what is this thing that I have suddenly put on the screen? This is no longer a simple list, an unordered list. What is this thing called? Feel free to put your hand up or turn your put your hand up for the audio. This is a stem and leaf diagram. Yes, Mbali and Zanele. Why is the stem and leaf diagram a little bit nicer to work with compared to my earlier list? What makes the stem and leaf a little bit easier to work with? What do we like about it? I like it. As a math teacher, I like it. It's organized, Ndudu. Yes, it's organized. It's also ranked. So the very first number in this stem and leaf plot is actually 11. It's 1 for the stem, 1 for the leaf. Then the next number is 12. Then the next number is 13, but there's 2 of them, and so on. And the last number in my list is going to be 72. And what I love about the stem and leaf plot is it's so nicely organized that I can see like which, I can just see it so much more clearly. Yes. Okay. Now, I want you to work out for me how many items are there in this data set, what we call N. How many items are there in this data set? We call that the N, the number of items in a data set. So 2, 3, 4, 5, 6, 7, 8, 9. There's 9 in that thing. So what do we get as our n? Okay, we have n as 29. Okay, now what I want you to do is there's 29 items and they're arranged from smallest to biggest. I want you to try and find me the median of this data set. So what is the median of this data set? Off we go. Use what we used in what I showed you earlier. You can use, I would advise using the position calculation. So first of all, you find the position of the median. And then once you've got its position, you can write down what the median is. And I'll just give you the position calculation formula to start with. How did I determine the n? Michelle, what I did was each one of these things is a data item. And so I counted 1, 2, 3, 4, 5, 6, 7, 8, 9 in that row. 1, 2, 3, 4, 5, 6, 7 in this one. 4 in this. And I just counted up how many of these items there were. And now I'm saying find the median. Now the median is the middle of the data. It's written from smallest to biggest. But luckily in this one, it's already written smallest to biggest. But I need to figure out kind of how to do this calculation. And I think n is 29. And so that's going to be 30. And this is going to be the 15th position. So what is the 15th? What is the value of the number that is in the 15th position? I have to count. 2, 3, 6, 9, 10, 11, 12, 13, 14, 15. But that isn't the number 7 because there's a scale here. The number of the median is going to be 27. And so there's 50% of the data above the median, and there's 50% of the data below the median. Okay, cool. You've done well so far, everyone. Let us have a break because we have done well, and I think we need to have a break. So I want you to turn on your cameras. And Kia, if you could just tell me who is the most enthusiastic participant. I want to see who I can invite to my gym class one day. And I want you to stand up. And I want you to start by just swing those arms. Be free. Just swing those arms. They are free and look off into the distance. So your eyes get a nice break. You've got to take care of your eyes. And then while you're taking care of your eyes, you can start to roll your shoulders. You can roll them back. Switch your eyes to another point. And you can roll your shoulders forward. And then let's do a tricep stretch just to release some of the tension in our shoulders. Okay. And then once you've done the one arm, switch to the other one. Oh, that feels good. Yo. Bad and good at the same time. Okay, and then let's do this one. But this is the tricep one, sorry. And then let's switch. Oh, I can feel my shoulders inside. And shake it out again. Okay. Let's take 3 deep breaths. So nice long inhale through your nose, nice long exhale through your mouth. Okay, and hopefully you felt some oxygen flooding through your body. And let's do some stuff to pump the blood around your body. Let's do 20 jumping jacks. Make sure the space around you is clear. You're not going to whack anyone. A jumping jack is just like this. And we're going to start in 3, 2, 1. Let's go. 2. Halfway. And we're done. Okay. And I definitely feel like my body is more with me than it was a moment ago. Let us do some math 24 just to keep our brains ticking over in adding land. The way it works is you're trying to get to 24 using all four numbers on a card. See if you can claim one for yourself. Oh, Aratiwe, we should do the pen flip. Yes. Okay, I'll do that the next time. It's been a while since I've done that. I'm so glad you remember it. It's one of my favorites. It's so good for getting your brain to zone out. So we're trying to get to make 24. And Ayanda has put in a nomination. So 8 minus 7 is 1. And 1 plus 3 is 4. No, 7 minus 8 is minus 1 plus, not quite. 8 minus, oh yes, 8 minus 7 is 1. And then you've used up that, and then you can just say times 3 times 8. Mbali and Zanelia, I think. Oh, but okay. Yes. Mdudu, yes, that's right. Okay, so the red card is done. I'll just give you a little bit more time on the blue one, and then we're going to head back to the lesson, because I think we've had a nice break. 8 times 3 times 8 minus 7. Ah, Michelle, you're absolutely correct, as long as you had brackets around your 8 minus 7. So Kwakanya has said, for the next one, 5. Oh, well done. Yes. So 5 times 6 is 30, minus 2 minus, oh, wait, no. 5 times 6 is 30, minus 2 is 28, minus 2 is 20, not quite, but close, What if, I'll give you a hint. What if you went 6 plus 2 instead? So you went 6 plus 2 gives you 8. What else could you do to get 24? Who feels like they might have some of the... Keisha, let's go to you. What do you think it is?
I have a question. Where's
Okay,
the
well, it's
6
just...
coming from?
Oh, it's at the bottom here.
It's not a 9.
So, no, because the little line is always at the bottom.
Oh,
Okay, so I see 5 minus 2 from Mdudu, and then I see 3 times 8 would give me 24. So 6 plus 2 is these ones, and then 5 minus 2 are those two, and then we multiply them together. All right, well done, everyone. I think that was a good break. Let me know in the chat if you enjoyed the break, if you feel refreshed, and we're going to go back to that actual main lesson now. Okay, so let's do a multiple choice question. I want you to, this is the temperatures of the month, and it's in Fahrenheit, which is an overseas thing, but that's fine. Find the mean temperature for the year in terms of these temperatures given. This is actually for London, England. So, and it's in Fahrenheit, but that's fine. Find me the mean of this value here. Remember, the mean is a measure of where the middle is. And I want you to, you can use your calculator. There's different ways of doing it, but for today, I'm kind of staying with, I'll spend a lot of time with the calculator in the next lesson and future ones. But today we're kind of just going, what is the mean? How do we find it? And which of the options do we think is the correct one? So I think we have to add up all of these items, right? So 38 plus 39 plus 43 plus 46, and we get a total, or we get the sum. What are you guys getting as your sum? What are you getting as the amount that you add up to? So it said that it's 594. Did anybody else get 594? Yep. So we go 594 divided by 12. And if we get 594 divided by 12, let me have a look here. 594 divided by 12. I'm just using my calculator. I get 49.5, which is B. Okay, so that is B. Now, that was the mean. That was equal to the mean. I want to know what is, actually, no, let me not do that now. That'll be a bit too complicated because it's not arranged in order. So let's go on to another one. Okay. What is the mode of this data set? What is the mode of this data set over here? And you've got four options. You've got A. Pen is being funny. Let me turn this off and on again. So I'll call that A, B, C, D. Which of the following is the mode of this data set? So I'm going to highlight ones that I think the mode occurs the most often. So that occurs quite a lot. But so does that. Is there anything else? It looks to me like the correct answer is C. Yeah, because you can see that the frequency of 7 is 3 times, the frequency of 14 is 3 times. And so we can have two modes. We say it's bimodal. It has two modes. Okay, now I want you to find me, this is a bonus question. Can you find me the median of the set of numbers? Can you find me the median of the set of numbers? If the 7 were 3 and the 14 were 2, is it still the same answer? No. And Mbali, in that case, 7 would be the mode. The mode is the one that is the measure of the middle that occurs the most often. So for me, I don't know what the median is until I arrange the data. So I'm careful and I go 2, 3, what have I got then? Then I've got 7, 7, 7. So, and then I go 14, 14, 14. And then I have a 20. Now, how many items are there in my data set? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the position of the median, I'm using the symbol Q2 for the median, the position is going to be a half times n plus 1, and n is 9 because there's 9 items in the data set. So position is going to be the 5th position. And so I count 1, 2, 3, 4, 5, and it looks to me that the median has a value of 7. So the median has a value of 7. Give me a thumbs up if you followed how I did the position calculation, and that what you see with the median is there's always going to be an equal amount above and an equal amount below. And that's what this calculation helps you do. Okay. So that's why I distinguish between the position of the median, which is different to the value of the median. And the value of the median, let me just write it here, the Q2 value is 7. Okay, you guys are doing swimmingly, so let's keep swimming. If there is a question, I encourage you to raise your hand to ask it, because we can all benefit from your question. Okay, it said the number of pages. Orokanisa, what is your question?
Hi, sir.
Hey, what can I do?
So, sir, I wanted to ask, if you find the position, maybe it's 10,5, do we round up?
Such a good question. Okay. What happens if the position is 5.5? Okay. If the position is 5.5, it falls between the two numbers. And what you do is you then take the average of the two numbers. So you take the average of the two items that are closest. Such a good question. Thank you for that. We all benefited from that question. Okay. Let's do this one. Which of the 4 choices do you think is correct here for the mean? What's the mean number of pages? And then I see some other students have raised their hands. Let's have a look. Let's unmute Tando.
Sir, I didn't hear you when you responded to a question about rounding off or not.
Okay, so all I said, the question was, if we have, what happens if the position doesn't give you a whole number, it gives you something like 5.5, what do you do then? And what that means is it's fallen in between the 5th and the 6th value. It falls somewhere in between. And then what we have to do is we take the average of the two numbers that are closest. So if the position was 5.5, you have to take the average of 7 and 14, which would be 21 divided by 2, 10.5. But so you take the average of the two numbers if you fall between them. Does that make sense?
Yes, sir.
And Oratiwe, what's your question?
Evening, sir.
Hey.
So regarding the question Orkanisa asked, so in this case, how would we calculate that? And can you just break it down?
Okay, if the position wasn't the 5th position, it was a decimal, you would have two numbers that it could be. It could be 7 or it could be 14. And all that we do is we take the average of those two. So we add them together and divide by 2, and we get 10.5. And so the value of the median would be 10.5 if that position was true. But I'm making it up, Pat. In this case, it's not. But I'm just using it as an example.
Thank you very much, sir.
Pleasure. And the correct answer for this one was going to be 9. You just had to add up 9 plus 8 plus 12 plus 6 plus 10, and then divide by 5. And you'll get the answer 9. Okay, let's keep going. Next question. In order to find the median, the data must be sorted from least to greatest first. True or false? What do you think the answer is going to be here? You are correct. It is true. So for the mean and the median, you don't need to sort the data, but for the median, you've got to be organized. And that's why teachers like the stem and leaf plot, because it does the organizing for you, which saves us a bit of the mess that comes if you're trying to order it. Okay, well, I think it's time for a old exam question. So it says here, a school held a sports day. One of the items on the program was an obstacle race. Teams of 10 parents and learners participated. The table below shows the time taken in minutes by each member of a particular team to complete the race. So question 1, how long did it take for the fastest member of this team to complete the race? And then determine the mean time taken by Okay, so basically I'm going to change this question to say, how long did the fastest team take to complete the race? And then I just want to know, what is the average time or the mean time taken to complete the race in minutes? So let me know, first of all, for 1.1, how long did it take for the fastest member of the team to complete the race? Okay, and the sneaky thing about this is in a race, the least time wins. And so 4 minutes will be the fastest time. So sometimes watch out for that, because our brains always bigger is better, but in terms of a race, less time is better. Okay, now find me the mean number for the data set. Find me the mean or the average time for this data set. So there's 10 items. And how much do we get if we add these all up? So we take our calculator and we go 4 plus 12 plus 13 plus 16 plus 17 plus 18 plus 20. And we should get 169, which gives us an average time in minutes of 16.9 minutes. Okay. So now I want to know, what is the modal time or the mode for this list of data? What is the modal time for this list of data? Remember, the mode is a measure of where the middle of the data is, but in this situation, it's actually not the greatest measure, but it will be 22, because that's the only value that occurs twice. The mode isn't very helpful for continuous data, really, but it's good to know how to do it. Okay, getting towards the end. What about the median? Find me the median time from this list. What is the median time for this list? Or what is the value of Q2? So the position, this is kind of what you were asking about. It's the 5.5th position. It's not an exact thing. So where is at falling? It's ranked. It's in order from smallest to biggest. 2, 3, 4. So it feels like it falls between 17 and 18. So what's the value of my median going to be? The median is going to be 17.5, because I've just added 17 plus 18 divided by 2. Yep, exactly. Now, in this lesson today, I've really just made it clear to you the different names for data, continuous and discrete. I've spoken about how data can be in a list or it can be in a table. And then I focused on how to measure where the middle of the data is, or the measure of central tendency. And we focused on the mean, the mode, and the median. Now, in the next lesson, we're going to focus on how to measure how spread out the data is. And I just want to quickly show you something that will help us in the next lesson before I let you go. So we can also find, instead of finding the median, or what we call quartile 2, it's also possible to find what's called quartile 1 and quartile 3. And what those things are is, instead of being halfway through the data, you go a quarter of the way through the data. And so I just want to show you as a preview of the next lesson how that would work. So if you want to find Q1, which is the first quartile, or a quarter of the way through the data, you first do the position calculation, and the position calculation is slightly different. It's just going to be a quarter times n plus 1. So in this situation, that is going to be a quarter times, what was it? It was 10 items. So, and then my position is going to be 2.7 no, it's going to be 2.25. And so where is that going to be? Well, that is going to be between my second and my third item. And what is the value? How would I calculate the third quartile or the upper quartile? Well, that calculation will just first do a position calculation, which goes like, sorry, it's not going to be a quarter, it's going to be 3/4, because it's now going to the upper quartile, and that would be position 7.75. And where would that be? Well, that's 5, 6, 7. So the third quartile would be between those two values. And so in the next lesson, I'm going to talk about how we find not just the median, which is called the second quartile, and the median divides into the top and the bottom. We also talk about how we divide up the 2, 3, 4, 5, 6, 7. Yeah, also how we divide up other parts of the data. Okay, cool. That is it for today. That was just a little preview of the next lesson. Kia, if we could just put the link to the poll in the chat. And yeah, I hope you enjoyed tonight's lesson. I see, Tando, you have a question, so let's go to your question. What can I do for you, Tando?
Sorry to take you back, but when we were doing the stem and leaf diagram, I didn't understand how you got the answer regarding the key.
Oh, okay. So the stem is like the tens column. The leaf is like the units column. So for example, if I went to this item here, the tens column comes from here, which is 2, and the leaf is like the units column, so it's 21. Does that make sense?
Oh, okay.
And like down here, this wouldn't be 0, it's 60.
Oh, okay.